Okay, now we are going to solve the twosum problem with the most optimized way, which will be acceptable in the interview, and like that is the recommended method that you have to follow. I have already explained the problem in the previous video while we were trying to solve it with the brute force method, but let me just give a quick review. There is a list of integers and there is a target given. We need to return the indexes of those two elements with sum equal to the target. Now let's solve it with a single traversal. Here the data structure we will be using will be a dictionary. Let me first tell you how we are going to solve it. We already have given the list of nums, which is 2, 7, 11 and 15, and the target will be 26. Now, what we have to do, if x plus y, so suppose x and y are the two integers that sum equal to the target. That means y will always be equal to target minus x. That's a basic mathematical equation. So, if we have already traveled one element and if we can find if target minus y is already traveled or not, let me just show you if target minus y is already traveled or not. Why target minus y? Because it is the another number. So if x plus y, which is first number and second number, is giving us the target, that means second number minus the target gives us the first number. That's why we are looking for x. Target minus y gives us x. Let's check. So to solve this problem, we need to make a record of notebook where we'll be storing the already traveled elements corresponding with their index values. Let's check for 2, because while we will travel it single time, we need to look for 2, the first element. We need to check target minus 2, which is the target to find, is 24. Have we already traveled this 24? No. If we have not already traveled it, then we will just store it in our notebook, which is the value. Key will be the value of the number and its index will be the value of corresponding to that key. So 2 with 0 index, we have stored it in our notebook. Now let's check 7. 26 minus 7 is 19. Have we already traveled this? No. Let's add 7 with its index. Done. 11. Have we already traveled 26 minus 11, which is 50? No, we have not already traveled it. So let's store it with its index also. Now the last number is 15, because we are jumping from 2, then 7, then 11 and 15. Yes, 26 minus 15 is 11, and when we will look it in our notebook, 2, 7, 11. Yes, I can say that we have already traveled 11 and its index is 2. That means we know the answer, and what we have to return? The value, the index of the value, which is 11. The index of 11 is 2 and the current index, which is I. Let's solve it with the Leetcode. First, we are going to use a dictionary named as visited. Then we are going to use the for loop for I in range len of nums. Here we are going to travel it till the end, not like the brute force method till L len of nums minus 1. How we can access the nums of I, and its index will be I. So here we can access the value and its index is I. We are going to make the if condition, which is, so let me just name it difference, which will be the target minus the present value. What is the present value? Which is nums of I. Then we have to check if have we already visited the number target minus y, which is in case here is diff. Have we already visited diff? If diff in dictionary. Yes, if we have found the solution that we have already visited, what do we have to return? We have to return the current index, which is I, and the index of the diff where diff existed. How we can get it? We are going to call it from the dictionary visited.get and diff. It will return us the key, the value of this thing. And if we do not find it, what we are going to do? We are going to add the current number in the dictionary corresponding to its index value. So we are going to call it like dictionary of nums of I at its index. So we have already solved this problem. Let's try to run it and then submit it. All right. Okay, it's actually visited. Here also we have to modify it to visited. Now let's just directly submit this problem. Perfect. We have achieved the, we are at the first draft. So that's good. Beats 100%. So yeah, that's how we solve this problem in the interviews, and you can already see that we are traveling the for loop only one time. That gives us the time complexity as big O of n. Thank you for the video. Stay tuned for more videos.